We all know the most powerful AI models are incredible, but let's be honest, they come with a big catch. There's this constant tug-of-war between power, speed, and cost. Well, in this explainer, we're going to dive into two really brilliant techniques that are completely changing that equation, making the best AI faster and cheaper for literally everyone.
So, you've probably noticed this, right? It's the big paradox of modern AI. You want the smartest model, the one that feels like a genius, but you also want it to be snappy and, not break the bank. So what is the fundamental bottleneck that's forcing this choice? Turns out, it's all about how these models actually think.
The secret is in how they generate text. They're what's called autoregressive. It's a fancy term, but it just means they build their response one little piece at a time, token by token. So to write a single simple sentence, a massive model might have to run its entire incredibly complex calculation a dozen times, one right after the other. It's inherently slow.
And this one-by-one process creates two huge problems for us. First, you get high latency. That's the annoying delay that makes the chatbot feel sluggish and clumsy. And second, you get massive costs, especially when you're talking about these new, complex AI agents that have to do a lot of thinking and planning before they act. Okay, so to really get why the solutions we're about to talk about are so cool, we need to quickly get on the same page about how we measure performance. It's not just one thing. There are two key ideas, and they're often pulling in opposite directions. First up, we have latency. The easiest way to think about this is time to first word. When you ask a chatbot a question, you want it to start replying instantly. That feeling of immediate response, that's low latency, and it's absolutely crucial for any app that's supposed to feel interactive and conversational. And then, on the other side, you have throughput. Now, this isn't about just one person's experience. This is about the whole system's capacity. How many different requests from all the users can the service handle at the same time? Higher throughput means you can serve more people, which is the key to managing a popular service and, of course, keeping your costs down. So, let's just boil it down. Latency is all about the speed for you, the individual user. Throughput is about the capacity for everyone using the system. And here's the kicker. Improving one can sometimes make the other worse. It's a really tricky balancing act for engineers.
All right, now that we've got that down, let's tackle problem number one, speed. And the solution is an awesome method called speculative decoding. You can think of it as a really clever guessing game.
The whole idea is actually borrowed from a classic trick that high-speed computer processors have been using for decades. It's called speculative execution. The core idea is simple. Why wait to be 100% sure you need to do something? Just do the work ahead of time. If you were right, you just saved a boatload of time. So here's how it's applied to AI. You take your big, powerful, but kind of slow master model, and you pair it with a small, super fast draft model. This little model acts like a quick apprentice. It looks at what's been written so far and just fires off a guess for the next 5 or 6 words. And here is where the magic happens. Instead of the big model chugging along, generating one word at a time, it takes the apprentice's entire draft, all those guessed words, and checks them all at once in a single, super efficient step. If the apprentice guessed right, you just generated, say, 5 tokens for the price of 1. It's a huge win. But you know the best part? This is a completely lossless trick. The final output is mathematically guaranteed to be exactly the same as if the big model had done all the work by itself. You sacrifice absolutely nothing in terms of quality. So, what does this all add up to? A pretty massive boost in speed. We're talking about a 2 to 3 times speed up in real-world applications. For anyone trying to build a responsive AI product, that is an absolute game changer. So, we've tackled speed. Now let's switch gears and talk about the other big monster, cost. And for this, we're going to look at a new innovation that's aimed at these really sophisticated AI agents, the ones that can do complex, multi-step tasks. And believe me, they have a big cost problem. See, these advanced agents, they work in a loop. First, they plan. They use a really powerful and therefore expensive model to figure out a strategy. Then they act. They execute that plan. The problem is that the planning part, the reasoning, that's where almost all the money is spent.
Now, you might be thinking, hey, why not just save or cache the results? Good idea. But traditional caching doesn't really work here. It can't tell the difference between the general reusable plan, think of it like a recipe, and the specific details of your request, which are like the ingredients. So if you ask it to summarize different data each time, the old cache is useless.
This is where this new idea, agent-tick plan caching, comes in.
It's like having an AI with a recipe book. First, it pulls out the core intent of your request. Then, it checks its recipe book for a similar plan template. If it finds one, great. It uses a tiny, cheap model to just plug in your new ingredients. Only if it can't find a matching recipe does it have to call in the expensive master chef to create a new one, which, of course, it then adds to the book for next time.
And the result of this? Well, a picture's worth 1,000 words. Look at this chart. The cost difference between running the agent the normal way versus using this plan caching method, it's just dramatic. It completely changes the economics of using these powerful AI systems.
And let's put some hard numbers on that from the Stanford research behind this technique. Agentic plan caching slashed costs by nearly 47% on average. And here's the kicker. It did that while keeping over 96% of the original accuracy. That is a trade-off you take all day long.
And if you're wondering if the caching system itself adds a bunch of cost, the answer is nope, not really. This table shows that the overhead from running the cache is tiny, about 1% of the total cost. The huge expense is that large planner model, and this whole system is designed to avoid using it as much as possible.
So, let's just take a step back. We've made AI faster with speculative decoding and way cheaper with plan caching. And these aren't just minor tweaks. They really represent a fundamental shift in making the most powerful AI practical enough for the real world.
So let's just recap the big ideas. We've got speculative decoding, which attacks the speed problem by smartly guessing ahead. Then we have agentic plan caching, which crushes costs by creating a reusable recipe book of plans. The bottom line is that these solutions make top-tier AI practical for real-world use, and crucially, they do it without any meaningful hit to quality. And this isn't just a win for big tech companies. This is about democratizing access to powerful AI. As the researchers from Stanford put it, making this stuff cheaper means that smaller companies, universities, even individual developers can now actually afford to build and use these incredibly powerful AI agents. It levels the playing field.
And that really brings us to the final and most exciting question. For a long time, the massive cost and sluggish speed of the best AI have been huge roadblocks. Now that those barriers are starting to crumble, the real question isn't if we'll see a new wave of innovation, but what amazing new things are we all going to build next?